Hello everyone, today we are starting the series of solving previous year questions based on GATE examination of different engineering branches. So we are starting with a question based on probability first. Let's get started with the first question. It is given that the probability we have to find of the number selected at random between 100 and 999, both inclusive, that will not contain the digit 7. That means that 3-digit number should not contain 7 as any of its digit. So you see, if we talk about digit, how many total digits we are having? We have from 0 to 9, so total 10 digits. If we see the choices for the first place, and we have to make sure that it lies between 100 and 999. So for the first place, we can't use 0 and 7 we can't use. So two choices are gone. So how many choices we have left for first place out of 10 digits? So we have total 8 choices. Similarly, for the second place, we can't have 7. Rest any digits can be there. So for the second place, how many choices we have now? Again, 9 choices. Similarly, for the third place, except 7, we can have any digit. So 9 choices are there. Now, which rule is being applied here? So the rule is our multiplication rule. We all have studied this. If we have a task, let's say two tasks, 1 and 2. The task 1 can be done in m ways. Task 2 can be done independently in n ways. Then how many total number of ways to do these two tasks together? It is going to be m by n. So here we have total number without 7 as any of its digits using multiplication rule. First place we have 8 choices, for the second we have 9, and third also we have 9 choices. So if you multiply this, 8 times 81, it is going to be 648. Now what are the total number between the given limit? So total number which are there between 100 and 999. We have to include both. So it is going to be 999 minus 100 plus the last number, which is 999. So this will give us 900. So from here we can write down the required probability of all the number without digit 7 is going to be 648 divided by 900. So this is our final answer. So the correct option is going to be option C. It says that 2 dice are thrown simultaneously. Probability that at least one of them will have 6 facing up. So remember this note here. Whenever we have the case at least, how we solve this? We solve this using the complement, that is 1 minus none. What does that mean? Is probability that at least one of them is 6. We can write it as 1 minus probability that none of them is 6. So this is how we use the complement whenever the question is at least. So probability that none of the dice show 6. So we have in a roll of dice, what are the sample space? It is from 1 to 6. Now if it does not have 6, what is the probability? It is going to be 5 by 6. And again for the second case also no 6, so we have probability 5 by 6. Simplifying we get 25 over 36. So what is the probability that at least one of them is 6? It will be 1 minus none. So 1 minus 25 over 36, which gives the answer as 11 over 36. So the correct option is going to be option C. Moving to the next question. It is given that the probability the top and bottom cards of a randomly shuffled deck are both ace. So we know that total number of cards is equal to 52. And how many total ace card we are having? So we have total 4. Consider the top card is ace, and in between we have 50 card, and again the bottom card is ace. So what is the probability that this top card is an ace? So for that the probability will be 4 over 52. Now after getting this as ace card, how many remaining ace card we have? So the total number of remaining ace card is going to be 3, and total number of card will also get reduced by 1, so it is 51 now. So what is the probability for the bottom card to be an ace? It is going to be 3 divided by 51, and both these cases are required. So what we will use is called the multiplication rule, correct? So from this we will get the required probability that the top and the bottom card are ace. It will be 4 over 52 times 3 over 51. This is the required answer. So the correct option is going to be option C. Now moving to the next question. It is given that the probability that it will rain today. So probability, let us denote this as event A. Event A is that it will rain today, and we consider event B as it will rain tomorrow, correct? So probability of A is given to be 0.5 and probability of B is given to be 0.6. Next, the probability that it will rain either today or tomorrow is 0.7. So either or means what? We have been given the union. It is given to be 0.7, and we have been asked the probability that it will rain today and tomorrow. So whenever we have this keyword and, it denotes intersection or denotes union, correct? So we have been asked what is the probability of A intersection B. So which concept applies here? The concept is called as the inclusion exclusion principle. And what does this principle says? The probability of A union B is nothing but probability of A plus B minus probability of the intersection. So from this, if we substitute the values, union probability is 0.7, probability of A is 0.5, probability of B is 0.6, and this is what we have been asked for. Simplify this, 0.7, this is 1.1 minus probability of A intersection B. So if we find probability of A intersection B, that is going to be 1.1 minus 0.7, which gives the answer as 0.4. So the correct option is going to be option D. Now moving to the next question. A die is rolled 3 times. The probability that exactly one odd number turns up among the 3 outcomes. So we will get 3 outcomes, correct? So from this we can create 3 cases as well. Like one odd number should be there, so rest should be even number. So it can be first is odd, second even, third even, sorry. It can be this case also even, odd, even, or it can be this case even, odd. So what is the probability here? If we try to find out, that is quite easy. For an even number, if we see the sample space when we roll a die, so it is 1, 2, 3, 4, 5, 6. So probability that the number is even, it is going to be 3, because we have total 3 even number, 2, 4, 6. So 3 divided by 6 gives 1 over 2, and probability that it is odd, again 3 by 6, which is 1 over 2. So the first is odd, its probability will be 1 by 2, even is again 1 by 2, again 1 by 2. Here also we get 1 by 2 times 1 by 2 times 1 by 2. Similarly here also 1 by 2, 1 by 2 and 1 by 2. Correct? And again we will apply which rule here? So we have to apply addition rule, because either of the case can happen. So according to the probability that exactly we have one odd number is going to be, it can be either of the 3 cases, right? So what we will do, it will be 1 over 8 for the first case, because each is equals to 1 over 8 only. So we have to just add all the three cases, and this is nothing but 3 over 8. So the correct option is going to be option B. Now let us move to the next question. Now question is given as, this is the question. It is given that 7 car accidents occurred in a week, and all are distinct accidents. What is the probability that they all occur on the same day? So here you see, in a week we are having 7 days, and total we are having how many car accidents? 7 car accidents. So for each car accident to happen, we have 7 choices for each. So for 7 car accidents, how many choices we got? 7 for each. So again, using multiplication rule, we have total 7 raised to 7 choices. Correct? These are the total number of ways. Now, the question is to find the probability that they all occur on the same day. So all occurring on the same day, what does that mean? So if we consider the case like all occur, when I say all, that means what? All 7 accidents, let us say they occur on Monday. So how many ways are there? There is only one way, right? Or it can be the case that all 7 occur on Tuesday. Again, we are having 1 choices. Similarly, for Wednesday, also we have 1 choices. Till Sunday, correct? All can happen in any one of the days of the week. So total how many ways we are having? So total from here we will get 7. So the required probability that all occurring on the same day, it is going to be, so for this event how many choices we have? 7. And what are the total choices we are getting? We are getting 7 raised to 7. So simplifying this will give us 1 over 7 raised to 6. Hence the correct option is option B. Now let us move to the next question. So in this question, what we have been given, a company is assembling computers. The question is this: the probability of a faulty assembly of any computer is given to be 1 over 20, and the company therefore subjects its computer to a testing process. It is also given that the testing process gives the correct result for any computer with a probability of 3 over 4. What is the probability of a computer being declared defaulty? So let us consider the cases when the computer is actually a defaulty computer, right? So how to do this now? So we understand with the help of a tree diagram. Let us say here we are having a computer which can be either faulty or it can be non-faulty, correct? Now, if it is faulty and it goes to the testing process, correct? It gives the correct result for any computer with a probability. So there can be a correct result or there can be incorrect result for this faulty computer. Similarly, for this non-faulty also we can have correct result as well have incorrect result. What is the probability that it is faulty? It is given to be 1 over 20. And what is the probability that it will be non-faulty? So it is just a complement. So we subtract from 1, we get 19 over 20. Here it will give the correct result. The probability is 3 over 4. So here the probability will be 1 over 4. Again 3 over 4, 1 over 4. So in what all cases the computer is being declared faulty? If you consider that, you see here in this first case the computer was faulty, and if the testing is correct, That means yes, the computer is indeed faulty. And if you consider the second case, it is faulty and the result is incorrect. So the result will say is that it is non-faulty in the testing process. Sorry, here what we have to do is, if it is non-faulty and we are getting the correct result, that means yes, it is non-faulty. And if it is non-faulty and the result is incorrect, then the conclusion will be that it is faulty. So we have to just consider these two cases. So here what we are applying, actually, if you see, it is nothing but the case of total probability. Correct? So what I can write down, what the required probability that the computer is indeed faulty, it will happen in these two cases only. So we have to just multiply 1 over 20 with 3 over 4 first, 1 over 20 with 3 over 4, then plus the second case, which is 19 over 20 multiplied with 1 over 4. So if we simplify these two, we get 3 over 80, and this will be 19 over 80. Adding these two, 19 plus 3 is 22 over 80. So this will be our correct